So with 9x plus 1 equals 27, we could do common base. We could y1, y2. We could convert to a log only because there's one exponent. We agree? Today what we're going to learn is you can solve every single one of these by logging both sides. It's just sometimes like 75,000 steps. So you only pick that option usually if you have to. And the only time you have to log base 10 both sides is if you have two bases, two exponents, and you can't make a common base. So it's a very special time when you have to do that. Yeah. Yeah. So I'm going to show you how we could do this one by log base 10 both sides. So this is the fourth option, of which you usually will not choose unless forced to. Okay? So it's 9 to the x plus 1 equals 27. And I told you, basically we log base 10 both sides. Because what you do to one side, you just have to do to the other, right? So if you're log base 10 one side, you have to log base 10 the other. So we go log base 10 of 9 to the x plus 1 equals log base 10 of 27. Now some people will say to me, well, we don't have to write the base 10 if it's a base 10. You don't, but trust me, from all of the experience of me teaching this, when I used to not make people put 10s in here, people will drop the 9 into the 10 spot and they'll get it wrong every single time. They'll put the 9 in the base. So I always log base 10 so that I take the 10 and it fills up that base spot so you can't drop the number into it. Does that make sense? So log base 10 both sides. Now, there's also a rule, it's called the power rule. I'm just going to show it to you early because I want to be able to do this on a Friday because it's a shorter lesson. So the power rule states that if you have n log base, let's say b of m, what you can do is you can take the n and you can bring it up as the exponent. So you can go log base b of m to the n. Now this is an equal sign, so it can go both ways, correct? And when we're solving an exponential, the problem is that the exponent is in the variable, or the variable's in the exponent, not the exponent's the variable. Variable's in the exponent, that's our issue, correct? How we fix that issue is either doing common base, and then we can bring exponents down, or we've converted it to a log, and when we convert it to a log, it brings the exponent down, correct? This way, log base 10 both sides can also make the exponent come down. Why? Because the moment I put a log in here, I can take any exponent and drop it in front by the power rule. The power rule says if I have a log, I can take the n and I can also drop it in front, correct? I can bring it down here and I can bring down my exponent, or I can take what's in front and I can bring it up to my exponent. It can move either way as long as the word log is there, correct? And I need this exponent to come down, don't I? So if I log base 10 both sides, now can I bring the exponent down? Yeah, because that's power rule. As long as there's a log in there, you can take this exponent and you can drop it in front. So now I get x plus 1 in front, and I put it in brackets. And the reason why I put it in brackets is your first step is going to be log base 10 both sides. And then your second step is going to be to bring down exponents. By power rules. And then your third step is going to be to distribute. The exponent. It's not an exponent anymore, but I'm writing it as exponent because it was the exponent through. So when I distribute this exponent through, I'm going to get x log base 10 of 9. And then plus 1 log base 10 of 9. Do you see what I did there? I just went x log base 10 of 9, 1 log base 10 of 9. I just distributed the exponent through. Does everyone see that? Everyone where I am? X log base 10 of 9, 1 log base 10 of 9. Plusing it. And then it equals log base 10 of 27. So step 1 is log base 10 both sides. Step 2, bring down the exponent. Step 3, distribute the exponent through. Step 4, x's on left, terms without x's, on right. So x log 10 of 9 stays on the left. Do you see that? Does 1 log base 10 of 9 have an x in it? No, so it needs to move to the right. How do I move a positive 1 log base 10 of 9? Subtract. So I'm going to get x log base 10 of 9 equals log base 10 of 27 minus log base 10 of 9. Yeah, now we just solve. When they're these ones, when they're the other ones, it's going to be a little bit more work. When it's one with one exponent, it's not as bad. So we just have to divide by log base 10 of 9. And now I get x equals. Now I can just literally write them without the base 10s, right? The base 10s aren't needed. The only reason why I put the base 10s in is so that you don't take that number and drop it into the base 10 spot. That's it. So now I could just do log 27 minus log 9 over log 9. And this one's an easy one to type in because you can just use the log button, like the plain old log button, the one that's 3 up from the on button. You can go log 27 minus log 9. You're going to get a decimal divided by log 9. So you don't have to use the log base button. You can just use your basic log button. And what did I get for an answer? 0.5, which is good. Why is that good? Because it was the answer we got on all the other ones, right? 4 ways to find the same thing. This one's just often more steps, that's all. But this one always works if you log base 10 both sides when solving for an exponential. Yes. If you have 2 bases, 2 exponents, and you can't make them common base, you have to do this, which is what we're going to go to right now. Okay. On a separate sheet of paper, you're going to write out this one. 5 to the 3x. See, you actually don't end up with enough room if I gave you the printout, just so you know. 5 to the 3x equals 3 to the 2x minus 1. What was it? That equals 3 to the 2x minus 1. You know what's funny is I have them printed. This is how my brain is used. I have the notes printed. I just never did it yesterday. So you can write it out or you can use the notes. Oh my gosh, this guy by garbage can death. That would be like the worst death. Did you die by fire? No, I died by garbage can.
There's a garbage can.
Oh, I'm recording. I just think it's chlorine.
Yeah.
That's where you went with worst death?
I was putting chlorine in my hot tub last night.
Oh,
and
it's
I handed
bad.
some, and I like seized it.
Oh yeah.
I just laid it on my deck for like half an hour
You can actually die.
with chlorine in my lungs. It was
Okay.
awful.
Okay. So you can do this on a separate sheet if you want more room, because this actually is not conducive to room, but if you want to be a switcher, you can switch.
Wait, what page are we on?
I'll show you the actual.
Would the 3x go in front and it be
Where's that?
You're going down. Let's just get some. Yeah.
Okay, so we just learned.
Yeah. Okay, so we're here. Shh. I'll try and squish it just so you can see. If you're wanting to write it on here, you might have to squish a bit. You might be okay. It's up to you, wherever you want to do it. All right. So what's our very first step? We have to look and we have to say, can we do common base? Because if we can, trust me, it's way easier. So when I have two bases, two exponents, I ask, can I do common base? 5 and 3. No. If I can't, then I go to log base 10 both sides. If I can, I will never log base 10 both sides. It's way more steps. Okay? I can't make common base, so I'm going to take the log base 10 of both sides. So I'm going to go log base 10 of 5 to the 3x equals log base 10 of 3 to the 2x minus 1. What's my next step? Yes. Take the exponents, drop in front by power rule. So we're going to go 3x log base 10 of 5 equals 2x minus 1. And I put it in brackets so I remember to distribute. Log base 10 of 3. Like I said, the base 10 isn't a necessity, but people will drop the 3 and the 5 into the base when I didn't make them do this. So I had to figure out a way to get them to stop doing that. So I drop my exponent in front because of power rule. Then what do? Distribute. So I'm going to get 3x log base 10 of 5 equals 2x log base 10 of 3 minus 1 log base 10 of 3. What was my next rule? We distributed. What's my next rule? X is on the left. Anything without an X on the right. Now you could flip-flop. You could put X on the right. But I was just, consistency makes things happen better. So X is on the left. Anything without X is on the right. So I have a 3X over here. It's going to stay. What am I going to do now, though? This 2x log base 10 has an x, doesn't it? So how am I going to move it? Let's subtract it. Subtract 2x log base 10 of 3. And then what about this negative log base 10 of 3? Does it have an x? No, so it's going to stay over here. Negative 1 log base 10 of 3. Now, this next step we didn't have in the last one. This is where people often get stuck. Remember what I tell you, 98% of the time when you get stuck, what is the problem? Gcf, Common Factor, every single time. If it's in trig, it's also now going to be here. If you get stuck 98% of the time it's Gcf, it is here. What do both of those terms have in common?
Log.
That's true. What else do they have in common? That is not an incorrect statement. They both have an x in it. Take an x out. So we're going to take an x out of both of these terms, and we're going to be left with 3 log base 10 of 5. Minus 2 log base 10 of 3. And it equals negative 1 log base 10 of 3.
Why can't you go like 3 log base 10 of 5 and then x log base 10 of 5? Why can't you split those two apart, or can you?
Sorry?
Like the 3x log 10 5?
Mm-hmm.
Why can't you split those apart?
You can, but it won't be helpful.
Like the putting just 3 log 10 5 and then x log 10 5?
No, you can't do that.
Okay.
The multiplication has to be in the brackets, not in front.
Okay.
Yeah. So we just take an x out, and now we have this sitting here. What's happening? What operation is happening between the x and this bracket? It's a multiplication. So I'm actually extremely close to being done here. What do I just have to do? By both sides by what? This whole ugly looking bracket, right? Just divide it over. So if I want to type it in, I can just go negative log of 3. Remember, I can drop the bases off and just use the log button. 3 log of 5 minus 2 log of 3. If you're putting it all in at once, you will either have to use the alpha link button or the alpha y equals enter button to get a fraction, or you have to put the denominator in brackets because it's a binomial, correct? Because remember, if you don't, it's going to go negative log 3 divided by log 3, 5, and then it's going to subtract 2, which is not what you want to happen. You want it to divide this out, right? So if we go to type it in, we either have to put the denominator in brackets or use the alpha y equals enter button or the alpha link button. Get it to pop up. If you have the ones with colors, remember I told you you can use alpha xt theta n and it'll pop the fraction up really quick. If you have the ones that you plug into charge. If you go alpha xt theta n, you'll get a fraction right away. If you have the TI-84s, you have to go alpha y equals enter. If you have the TI-83s, you have to use brackets in the denominator because you can't get a fraction to show up. It's just how it is. So we'll go negative, not subtraction, negative log 3, close brackets divided by open brackets, if I'm using this old one, log 5, close brackets, minus 2 log 3. What'd you get? Negative 0 decimal 418? Yeah. You guys need to give answers like you believe in yourselves. You give answers like you think you're wrong or something. It's like negative 418. Be like negative 0.418. Lepp, that's what it is. And I'd be like, yeah, you're right, son. And I'd be like, you know what? It's very close.
What if it was
Very close doesn't
3,000?
I will 100% say it's very close, even if it's not. I will positively reinforce your crappy answer. It's totally fine. I won't make you feel bad. It's okay. Okay. Anytime. I will. I'll be like, you know, that's really close, but it's actually, yeah. Mm-hmm. Even if it was like 1 million. It's actually completely wrong, but I believe in you, and that's all that matters. All right. Look at this. A try. So try it. Go, because this one's a little different. Try this one. This one's a little different. I want you to do this one. Don't do this one yet. Do this one. Don't do this one. So I can do the other example. So we're going to go log. It's a really large marker. Okay, we're going to go log base 10 of 4 to the 2x minus 1. Log base 10 of 3 to the x plus 2. Drop it in front. 2x minus 1. Log base 10 of 4 minus x plus 2 in brackets. You don't forget to distribute. Log base 10 of 3. Then we distribute, boom, boom. So we get 2x log base 10 of 4 minus 1 log base 10 of 4. Distribute again, equals x log base 10 of 3 plus 2 log base 10 of 3. And then we get our x's together. So I'm going to subtract the x over. So I'm going to go 2x log base 10 of 4 minus x log base 10 of 3, because currently it's a plus, right? And then on this side I have 2 log base 10 of 3. And I have a minus log base 10 of 4, so to move it I'm going to add it. Add log base 10 of 4. And then I take out a GCF of x, so I'm left with 2 log base 10 of 4 minus log base 10 of 3 equals 2 log base 10 of 3 plus log base 10 of 4. And then I'm going to divide. 2 log base 10 of 4 minus log base 10 of 3.
I got 2.14.
Yep.
Welcome to the party.
He's invited. He got there. Okay. 2.14.
I didn't write the other one down. When you brought the plus 1 log 4 over.
You didn't.
I didn't.
Okay, this one is the extra one that everyone forgets about, so I'm going to star it. Because if it were me and it were before a test, I would study it. It's one everyone forgets.
All right, I'll give this one.
Oh, is this on the test? Jesus, literally just said that.
All right, we're going to carry on. So,
Just ignore me, it's fine.
I did.
Yeah. Just do that. It's fine.
Okay. So how is this different than the other one? It's x plus 1.
Even I can read that. Come on.
You're at the front. We just ignore him as well. All right. Technically what?
Never mind.
Go ahead.
Okay.
No.
So,
Just-
what is different between this one and the last one? This.
Three term.
There's 3 terms. There's a 2 sitting in front, correct? Do we see that? Okay. Now, if it was common base, if we could do common base, we'd go 2, 2, 2, and we would make that be 2 to the 1, and then it would just add with the other exponent, correct? If it was common base. It is not. We can't make common base. We agree? Can I divide the 2 over? No. The 6 has an exponent, correct? Can I multiply the 2 in? No, the 3 has the exponent. Do you want to know how many people multiply that in and make this be 6 to the x and then life is so nice? You're super wrong, but it makes a really nice question. And you will know to cry because you will y1, y2 and it won't match, correct? But then you'll group yourself together. You'll pull yourself together and be like, don't cry. Figure out how to do this correctly. So, log base 10 both sides. All right. So, we're going to go log base 10. Now watch yourself. It's 2 times, I put a little dot in there to remind myself, it's 2 times 3 to the x equals log base 10 of 6 x plus 1. Now this is where the power rule, or the product rule that I told you at the beginning comes into effect. So step 1 is log base 10 of both sides, and then we have to do product rule. Whenever you have these 2 stuck together like this, do you see that there are 2 of them and they're multiplied together? Now I told you when we have 2 things multiplied together, we can actually separate them by an addition. This is where things go wrong real quick. If you can get past this step, 98% of the people get this question right. If you can't get past this next step, it's bad. It's like 0. Okay? So, what do we do here? We use product rule. We have 2 things multiplied. We can separate them by an addition. So our next step is going to be to use product rule. So we're going to go log base 10 of 2 plus log base 10 of 3 to the x equals log base 10 of 6 to the x plus 1, and then we are back to just the exact same steps as before. Exact same steps. Just one extra step is the product rule in here. When you have 2 things multiplied, you can't make them common base. Do you see that? That's where we error all the time. It's just a sad, sad question. So, what's our next step now? Take your, take your exponents and drop them in front, because ultimately we need to get those exponents down or we can't solve. That's the biggest issue. That's why we learn logs for exponentials, is to get that exponent to drop in front, because we can solve anything as long as it's not sitting in that exponent, right? So we take the x, we drop it in front. We take the x plus 1, we drop it in front. Yep. Yes. And then this baby stays the same. Log base 10 of 2 plus x log base 10 of 3 equals x plus 1 log base 10 of 6. And then I can distribute my x plus 1 through. So I get log base 10 of 2 plus x log base 10 of 3 equals x log base 10 of 6 plus 1 log base 10 of 6. And then x is to one side, to the left side, everything else to the other. So I have x log base 10 of 3 stays on this side. And then I'm going to subtract the other x over. X log base 10 of 6. Do you see how all the steps are exactly the same after this point? It's just if you can get to the product rule situation where you add them out. Equals log base 10 of 6. And then I need to move this log base 10 of 2 over, so I'm going to subtract it. And then I do what? Take an x out. And then I can just divide it over, right? Do you see there's only one extra step? That's it. So you have to get past that product rule step. And then by adding them, and then boom, life is easy. Well, as easy as these questions are. So it would be log base 10 of 6 minus log base 10 of 2 divided by this whole bracket, which I don't have to write the log base 10s at this point if I don't want to. And I get negative 1.58. Did you get that? And I should walk away happy because I'm going to y1, y2 the question up top, and I'm going to get the same answer, and I'm going to be a happy person, right? Because they're going to match. Or I'm not going to do the product rule right, and I'm going to get an answer, and it's not going to match, and then I'm going to know, go back something, I'm missing something. What am I missing, right? Okay. I posted a review to Classroom with its answer sheet, so I'm obviously not marking it. That would be stupid, but whatever. It's due for Tuesday night. Obviously, you don't know how to do a bit of power rule, product rule questions, and logs, which we're going to finish up on Monday. Okay, we're finishing up on Monday. So if you see something you're like, I have not the slightest clue how to do this, it's probably because you don't have the slightest clue how to do it, because it's outside of what you've learned. So the questions for this week or this weekend are not a lot. So there's lots of time to be able to start working on that review. Okay? It's page 413, number 7. It has 4 questions. That's it. A, B, C, D. I'm showing this to prove a point. There are 4 questions. So there's plenty of time to start working on that review. Okay? Your test is next week.